This is a video on piecewise functions, and I'm going to give you like a little basis of what piecewise functions are. I'm going to show you how to graph it on the Inspire calculator, and we're going to practice graphing them here, and we're also going to practice finding the formula for a piecewise function. So let's do the first one. The basic piecewise function that you guys know, that you've seen and you've used for years but you've never thought of it, is, I'm going to show you this first and then we'll talk about the definition. If I told you y equals the absolute value of x, and you go, Mrs. Pond, that's so easy. That's absolute value. That means no matter what I put into this, whether I put a negative number in there, we'll say -3, or if I put in a +3, my answer is still going to come out positive because absolute value says whatever you put in, it's going to come out positive. And you're absolutely right. So this tells you what a piecewise function looks like. Because piecewise function describes a function in pieces. That's where it comes from. And this is how you're going to describe this function in pieces. So instead of using y, of course, we're going to use f of x because we're in calculus. So if I was going to describe what f of x equals the absolute value of x, if I wanted to describe what that was in a piecewise function, it would look like this. F of x equals. Now when we do piecewise function, we use this bracket. And most of the functions I'm going to do here have two pieces. And if you can see this graph right here, I have a piece going down here and a piece going up here. See, it comes to a point here. It's a function. So the two pieces are going to be as follows. That it's -x, and what you do is you say, okay, that's what the function is, and you got to tell me when does that happen. So you can use a semicolon or a colon, and you tell me when does that work. Well, that works when x is less than 0. So if you think about it, if I have a -1 or a -2, -3, if I were to place it right here, do you see where that would make it positive? So any negative numbers, you're really negating them to make them positive. You're like, okay. The other piece is it's just plain old x when x is greater than or equal to 0. So if you look at that, you say, yeah, if I put any number 0 or bigger, it's just the same number again. You're absolutely right. This is the basic definition of a piecewise because the absolute value you can describe in this manner. Okay, you can describe it in this manner. Now let's go through what the pieces of a piecewise function are. First you say f of x or y equals. Then you're going to see this bracket here that breaks it up into two pieces. Then you're going to see a function, so this is -x, and it tells you when it happens. Well, it happens when x is less than 0. Then you're going to see the other equation right here. When does that happen? When x is greater than 0. I call 0 the breaking point. That's where the function changes. And if you'll notice, 0 is only in one piece. 0 is only in this bottom piece because the equal. 0 is not in this piece, but it goes up to 0, but does not include it. So when you were going to graph this, so I actually graphed this already on a graphing calculator. And I'm going to go, here it is, all right. Now when you go to graph these on the graphing calculator, the cool thing is if you push this right here, if you push this button right here, see how it gives you a piecewise function? You can also have it in 3 pieces if you want. All right? So it gives you more than one options to graph this. All right? So I don't want that anymore, so let's push it back so it goes away. So let me move this out of the way because I really don't need it anymore. I just wanted to show you what it looks like. And it won't go away. There we go. Okay, so here is the piecewise function looks like, just like on the graph. And I actually put it in my calculator, and if you look at it, it's right there, just like what we put in. So your graphing calculator actually graphs it. The cool thing it also does is if we go under menu and go under your table, and we'll do a split screen table, it shows you the two pieces, and this is how it shows you. Look. It shows you as one function, so it shows you 0, 0, 0, and it shows you all the points, so you can graph it. The only thing is you don't know which piece is what, but it graphs it as a continuous function, which is kind of nice. All right, it's very nice. Okay, so I'm going to get it ready for the next one. So let's look at the next function we want to do. So I'm going to bring it over here, and I'm going to show you how you're going to graph this by hand, and then we're going to put it in the calculator to see if we're right. So here's a piecewise function. This tells me y equals, or f of x equals x squared when x is less than or equal to 2, and it's 6 minus x when it's greater than 2. And here's the breaking point. If you'll notice, it breaks at 2, and 2 is only in one piece. So you can only have the equal sign in one piece, and it's up here in the top piece. So when I have people graph this, this is how it looks. We're going to make a nice table here. okay? And we're going to put the two pieces here. Now when you do the pieces, they go top down, left to right when you graph it. So we're going to say y equals, or f of x equals x squared in this piece, and it equals 6 minus x in this piece. Now we're going to put some points in here. Now when I do this, I always start at the breaking point. So we're going to start at the point 2. The point 2 is in this piece. So if I put a 2 in there, 2 squared is 4. So the point 24 is on this graph. And it's less than or equal to 2, so I'm going to go down. If I put a 1 in, it's 1 squared, or 1. If I put a 0 in, it's 0 squared, or 0. If I put a negative 1 in there, it's going to square that. It's going to turn to positive 1. If I put a negative 2 in there and I square, it's a positive 4. And let me move this down just a little bit. And I can keep going so on and so forth, okay? And then we're going to graph that. The other piece, I always want you to start the breaking point. So we're going to start at 2. Now 2, you'd say, why are you starting at 2? It's not even in there. You're right, but it's going to be an open circle. It's going to go up to 2 because you can't stop at 1 because there's like a million points between 1 and 2. So we're going to start at 2. If I did this, it'd be 6 minus 2, or 4. And what I'm going to do is circle that because that's going to be an open circle on your graph. Now the graphing calculator is wonderful, but it doesn't show you open circles and closed circles. It gives you the main view. And in fact, it will not even show that point on the graph because it's not there. I'm going to show you how to do that. Now it's going to go greater than 2, so if it's 3, it'd be 6 minus 3, or 3. If it's 4, it'd be 6 minus 4, or 2. If it was 5, it'd be 6 minus 5, or 1. And if it was 6, it'd be 6 minus 6, or 0. Oh, sorry, that's a 0. Let me erase that. So now, this could keep going forever too because it's no. I have some points in which to graph this. So we're going to do kind of a hand sketch here. And I'm going to show you how this works. It's pretty neat, okay? Whoops, kind of wiggly. Let's erase this. Let's try to do this again. Okay, ready? Now, when we do a nice sketch, you got to show, whoops, got to show the x and the y. Put arrows on your graph, please, so you'll know. I'm going to put x and f of x, or x and y. So let's kind of graph the left piece. So we're going to say this is 1, 2, and it's 2, 4. 1, 2, 3, 4. So 2 4s on the graph. Then we have 1, 1, 0, 0, negative 1, 1, negative 2, 4. So what you have here kind of goes like this. Actually, it's a parabola, isn't it? Sorry, it's kind of bent. There should be more curved like this. All right, so that's a parabola, and it goes forever that way, and it stops here because it only works there. Now the next piece, I kind of graph that. The next piece, I have the point 2, 4 that's not really there, okay? But it is because it shows here, but it's an open circle for this part, so it's kind of nice. It's the same point for both. So then I have 3, 3, 4, 2, 5, 1, and it kind of goes like this. This is a sketch down to 6, 0. So that's what the piecewise function looks like. It's part of a parabola and part of a line. Now if I go to my graphing calculator, because I actually graph this, see how it works? It looks just like that. And right here at the point 2, 4, right here at this point, it's only the point 2, 4 is in the top piece, but because 2, 4 is here, it's like it looks like it's continuous. You don't pick up your pencil, okay? You don't pick up your pencil at all, and it shows you all the points if you look at the graph. All right? Let's try another one. I've got a piecewise function here. I've got x plus 1 is less than or equal to 2. So let's break up the pieces and get some points here and do our own little sketch before we put it in the graphing calculator. Oops, sorry. I don't know why I was doing that. So we have x. Oh, my goodness. Let's try this again one more time. X plus 1 is the first piece. I don't know why I put x and y. X plus 1. And the second piece is just 1. All right, so let's put some points in. We start at the breaking point, which happens to be 2. 2 is part of that, so I put 2. 2 plus 1 is 3. Okay, and it's going down. 1. 1 plus 1 is 2. 0 plus 1 is 1. Negative 1 plus 1 is 0. Negative 2 is negative 1. And so on and so forth. Now the other side's kind of easy. We're going to start the breaking point, which is 2. And 2 is not there, but if I were to put it in, my y would be a 1. And I'm going to put a circle around it because that's not really on that part of the graph, but it starts there. And then anything bigger, if it was 3, it'd be a 1. 4 would be a 1. Get the picture here, 5 would be a 1, and we keep going. Okay? Now, if we were sketching this, this is interesting, this graph, because here's your x and here's your y. You basically have one side a line, and you have another line, but the other line is flat because its y is always 1. So I have the point, okay, 2, 3, 1, 2, 0, 1, negative 1, 0, negative 2, negative 1. Okay, so here's a point, this is a point. So it's a nice straight line. Sorry, that goes this way. All right. The other piece, now this is where it's important, is 2, 1's not there, but if I was going to do 2, 1, it would be right here. So I'm going to put an open circle, and then I do 3, 1, 4, 1, 5, 1. So it's basically a straight line going this way. Now this is where it's important because this graph stops here, and it's not even continuous because it starts down here, even though 2, 1's not on the graph, but all these points in between belong. So that's a nice sketch of our graph. Let's look at the graphing calculator to see what we did. So let me go to the next one, and there it goes. But see how this is nice here? But if you'll notice, you can't tell which one's the closed circle. This is a closed circle. This is an open circle. So the graph is nice, and it's much better than the other graph used to be, but it doesn't really explain where the break-off is. Okay, so this point right here doesn't really exist, but it starts from there over. Okay? Now the last one, we're actually going to find the formula for one that's already set up. So this is how you do this, and I'm going to kind of go step by step. But I have two pieces. Remember what I told you, when we do the piecewise function, we go top down, left to right. So here I have f of x equals, and let's set it up because I have two pieces. So I'm going to have a function, and then I got to tell you what x is doing, and then I have a function, then I got to tell you when that works for x. Okay? Well, the cool thing about this is I see this breaks at 0. See where that breaks at 0? So that's an easy part to do. See how this is a closed circle and this is open, so the 0 is included in this part. So I can say x is less than or equal to 0. 0 belongs in this bottom piece because it goes left to right, top down. Okay? This one, 0 is not included. See how it's open? So this is x is greater than 0. So it did exactly what I told you. It's at the breaking point, and 0 is only in one piece. 0 can't be more than one piece. All right? Now let's figure out what the equation of this line is. Now this should be old hat because you guys are good at this. Let's pick some points. So we know the point 0, negative 2 is there. And let's pick another point. We know that negative 2, negative 4 is there. So if I have 2 points, I can come up with the equation of the line. I know that, let me move this down so we have some room. Oops, sorry. I know that my b, or my intercept, is negative 2. So I can say y equals b plus mx. I know the b already is negative 2. I just don't know what the slope is. Okay? So if I stack and rack and do the slope for this, I say slope is delta y over delta x. So I'm going to do top down. So it's negative 2 plus 4, because I'm subtracting a negative, and 0 plus 2. So I have a 2 over a 2, so my slope comes out to be a positive 1. That means my equation is negative 2 plus 1x, if you will, or negative 2 plus x. So I'm going to put here negative 2 plus x. That is the equation. So my function goes to here to 0, stops at 0 with 0 included, and that's my formula. Now let's look at the other piece. The other piece, I have a couple points too, and I have the point 0,3. Oops, sorry. I have the point 0,3. If you look at the graph, right here is 0,3. It's in between. And I have the point 3,6. I just picked a couple points on the graph. Again, I have y equals b plus mx, and I know the y-intercept is 3, so I have y equals 3 plus mx. Okay? Now if I do the slope between those two, 3 minus 6 all over 0 minus 3, I have a negative 3 over negative 3, so again I have a positive 1. So the slope here, the equation here is negative 3 plus 1x, or negative 3 plus x. Excuse me, positive 3. Why did I say negative? That's a positive 3, I'm sorry. So this one is actually 3 plus x. So what we just did was found the formula for that piecewise function. And the reason why I put it in with linear functions is because that's what you're doing. You're doing a linear, there are two linear pieces. I know I used a quadratic before, but if I'm going to have you find the formula for a piecewise, it's going to be a linear function. Let's check the graphing calculator. So let's look at this. I'm going to go over one because I already graphed this. And when I put it in there and I checked it, it's like perfect. It did exactly what I wanted to do. And I could check the points if I looked at my table, and you would see that it's there. And the other point is you remember you can't see the open circle and the closed circle, so you just got to know that you can check your points and it'll be okay. Well, that is the end of the Piecewise Functions introduction.